This is number 2 from the linear programming unit. Now, this is a word problem. And we have Aaron's hardware store makes and sells 2 different storm doors. Option A is going to take 2 hours to assemble and 3 hours to paint. It's going to sell for $98. And option B takes 4 hours to assemble, 1 hour to paint, and sells for $124. And the hardware store has 48 hours of assembling and 24 hours of painting available each week. The variables are defined for you, so X is option A and Y is option B. And using this, we want to set up a system of inequalities. So I think the easiest way to do this is to set up a table. So we have our constraints. So what we're limited by, which in this case we're limited by the assembly, or how long it takes to assemble. And we're also limited by the number of hours we have to paint. Your 2 columns are going to be your option A and option B. And that final column is going to be your total. So if we match these up, option A takes 2 hours to assemble, so we're going to plug that in there, and 3 hours to paint. What it sells for, we're going to use that a little bit later. Option B takes 4 hours to assemble and 1 hour to paint. And we're going to come back to what it sells for. And it says that the hardware store has a total of 48 hours to assemble and 24 hours to paint. So once you get all of that filled in, think about, like, it's going to take 2 hours for every option A plus 4 hours for every option B, and it can't exceed 48 hours, so it's going to be less than or equal to. Then for painting, 3 hours for option A plus 1 hour for option B, and that has to be less than or equal to 24. So these are 2 of your equations that we're going to use. There's 2 more that aren't specifically stated, but are really important, and that are these statements about x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Now those would be really important if we were graphing these, because those would give us, on our graph, this boundary line and that boundary line, which will restrict us into the first quadrant. But just make sure you don't forget about those 2. The last part of this asks us to write a profit function. So the profit function involves your 2 different things you're dealing with. In this case, are option A doors and option B doors. And option A door sells for $98, and the option B door sells for $124. So if we were to graph it and find the coordinates of the feasible region, this would be the function that we would plug back in to figure out what would create the highest profit for Aaron.